Hey everybody, I'm Chili and welcome back to Beginner C++ Tutorial 14. Today we're making a game. It's gonna be the snake game. Why the snake game, you ask? Well, just look at this cute ass motherfucking snake. Look at this and you ask me why? Get the fuck out of here. Now the snake game is gonna be a fun little project where we can test out our newly gained skills. I guess maybe some of you are getting tired of seeing the poo game every fucking episode by now. And this is going to give you guys something else to play with, to extend, to experiment on your own time. And Snake Game is somewhat of a rite of passage, I think, for game programmers, so it's fitting. It's apropos, as they say. Greetings, future Chili speaking. The video ended up being a little over an hour, so I had to split it up into two parts, and here's part A. By the way, there are some new topics introduced. Check the wiki, because I might put up some supplementary details about that shit. Anyways, enjoy the snakening. So some of you might be like, what the fuck is this snake game Chili's talking about? What is this bullshit? Well, here is a little video of the snake game in progress. This is basically the purest form of the snake game. You control the snake. It moves forward and you control its direction of motion, and the goal is to collect these, circles here, and every time you collect one, the snake becomes a little longer. Now, the game over condition is if the snake runs into another segment of its own body. So obviously, as you are collecting these goal pieces, the snake is getting longer, it becomes more and more difficult to avoid yourself as the snake moves, especially if it has a fairly high speed of motion. And that is the basics of the snake game. Of course, there are plenty of variations you can think of to, spice it up a bit. But at its core, that is the essentials. Now, before we jump into the actual coding, let's take a couple minutes and just think about how we want to approach the problem. So you may have noticed from the video, but the snake game is basically based on a grid. So the motion and the graphics are very coarse-grained. They're not fine-grained at the pixel level like you have in the poo game. So we can basically represent the game as a grid of rectangles, and that's what we're going to do. So we're just going to make the goal and the snake both be rectangles of different colors. And now, here's the thing. In the previous videos that I've done with the poo game, we've made it so that the dude and the poo and later on the goal and the meter, they draw themselves to the graphics object. So they're in control of their own graphical representation on the screen. And that's fine, but we don't want to do that in the snake game. Because, think about it, for the snake to draw itself on the screen, it is going to have to calculate the grid coordinates and the coordinates of cells in the grid so it can draw the rectangles that represent itself. And the same for the goal. That's going to be duplication of that calculation code to calculate the grid cells. You're going to be duplicating that in at least the goal and the snake, and in other entities if you decide to add them to the game. And then if you change something, if you change the dimensions of the cells or whatever, the way the grid is laid out, you're going to have to change that code in the snake and in the goal and in all the other entities. So what we're going to do is, instead of having these guys draw themselves directly to the screen, the snake and the goal, we're going to have a design like this. We're going to create a board class, and that board class is going to be responsible for drawing the grid onto the screen. And then the snake and the goal, they are going to draw themselves to the board. So the snake and the goal, they are only going to know about grid locations in grid space. They aren't going to be aware of pixels. And they're just going to draw themselves as rectangles on the grid in grid coordinates, and then the board is going to translate that into actual rectangles drawn on the screen. Now, between our entities and our board class, we're going to have a lot of functions and operations that deal in board space coordinates or grid space coordinates. So it's going to be int x and int y in grid space. And that's fine. But instead, up until now, we've been dealing with coordinates x and y as just separate integers. What I want to do now in this game is I want to create a class, and that class will encapsulate the x and the y. So it'll bundle them together, because when you have coordinates, they're always sticking together. You're generally always passing them together. So instead of having them as separate loose variables, let's bundle them together in a single data structure. So here's our starting code. You can download out the wiki. It's basically just a fresh framework solution, except I've added our draw rectangle functions from previous tutorials, because they're going to be useful to us, and I don't want to have to go over that shit again in this video. So you can get this stuff off the wiki page. So the first thing we want to do here is we want to add our location class to our project. So we're going to create a new item, header file. We're going to call it location. And add that up. So we're going to create a class, call it location. And we want int x, int y. Now here's where I would normally make this private, but I'm not going to do that here. And the reason why is because for this very simple data type, very basic idea of just lumping two values together for convenience and for organization, I don't think it is necessary to fully encapsulate this shit. In a case like this, for this kind of data type, I would just make the data members public and let you access them directly. Now, there is one thing that I want to bring to your attention, and that is there is another data type specifier where you can declare a data type called a struct. And sometimes people get confused about the difference between struct and class. And here's the thing about them. They are almost exactly the same, except in a struct, all the members default to public. And in a class, all the members default to private. That is the only difference between them. So they're basically interchangeable. And the way that people usually differentiate between struct and class usage is struct is for very simple data types that don't really have any behavior, don't have any complicated methods associated with them. And class is for more complicated objects, components that have a lot of behavior, a lot of member functions. There's no hard and fast rule, but that's the general tendency that I've seen. And in other languages like C#, that's actually how it works. Structs are just very simple data types, and class is things with behaviors. But in C++, they're interchangeable. But since this is just a very dumb data type, just dumb data, I'm going to name it struct for now. All right, let's get started on our board class. I'm going to get you to add a new header file, board.h, and just type this out here. You include your graphics, you set up empty board class here. Now, what data are we going to need for our board? Well, we're going to need, don't need that, static const expr. We're going to need the dimensions of the cells in the board. So we're just going to call this kind of constant expression int dimension, and we'll set that to, I don't know, 20. So cells will be 20 by 20 to start with. We're going to want to store the width and the height of the board for various validation reasons. And what else? Let's cache a reference to the graphics object so that we don't have to pass it in every time. So here is our data. Now we're going to want to create a constructor that initializes the graphics, and graphics ampersand gfx. I know I told you don't name your inputs the same as, oh wait. Okay, first off, we're going to be implementing this stuff in, where is it? Actions, create definition here. We'll implement it in a CPP file. Now, remember I said before, don't name your constructor parameters the same as the name of the members. And that's a good thing, but let me just show you why it's possible that you could name them the same. You can do this and it works fine. And the reason is because in the class initializer, it's going to assume that these guys are all members. And so that's why they won't alias to these guys. And then inside the actual parameters that are used to initialize the members, it's going to pick the one that's the closest scope, which is going to be the locals. But I mean, you probably still should give them different names. I'm just demonstrating this for the shits and giggles. So, initialize our graphics reference, and we'll just set width and height in here, in class initializer. And that should be fine. I mean, I guess I could even make these guys static const expressions. Not like the width and the height are going to change throughout the game. So let's just make them static. All right, now we need functions to draw rectangles to screen. So void draw cell. All right, here we need to include location. There we go. And this is going to take a location. So we'll just go location, and we'll pass it by reference since it's not just a simple data type. And then we're going to need a color C. And this is going to be not const, because it's going to be changing the graphics member. So just like that. And then we're going to create the definition. And this is just some basic math, right? So we're going to go graphics, and we're going to go draw rect by dimensions. Now, the start X and the start Y, what are they going to be? Well, it's going to be location.x times dimension. And location.y times dimension for the Y, right? Because if you got a grid like this and the cells are 10 by 10, it's going to be, the first one, the top, the Y coordinate is going to be 0, the next one's going to be 10, 20, 30. So you just multiply the grid coordinate times the dimension of the cell to get this position in screen space. Then the width and the height are just going to be the cell dimension, and then the color is just going to be color C that was passed into the function. Now, one more thing you can do, you don't have to, but it might be nice, is to add some assertions in here, just some sanity checks to make sure that someone isn't trying to draw outside of the board. So you can add some assertions here. It's just like the assertions for put pixel, basically. And if you add those in, you just got to make sure that you include assert. And there you go. All right, now let's test out our board. It's always a good idea to test your components before you continue on with a new part of your program. So we're going to include board into game.h. And for user variables, we're going to add a board. I'll just call it board BRD. And let's add some random. Let's add a random number generator. So I'm going to have to include random. And then we'll include the random number generator. We'll head over to game.cpp and initialize our members. Make sure you put double parentheses after the random device here. And then we're going to code up our test. And what I have in mind here is we're just going to put random colors into each tile of the board. So what we want to do is we want to create a distribution that we can use to generate random colors. Colors go from 0 to 255. Now we're going to loop through Y grid coordinates. Now wait, I have no way of getting the dimensions of the grid for the board. So what I'm going to do is I'm going to go into board.h and I'm going to add some functions to get the dimensions of the grid, like this, and then implement them like this. Now back to our test code here. We're going to finish looping through Y grid coordinates, or looping through rows like this, and then we're going to loop through each cell in the row in X coordinates like this. And then for each cell in the grid, we're going to create a location object, and we are going to create a color object that's been randomly generated from our distribution. Note that our location structure doesn't have a constructor, so we can't call it like this with the round braces XY, but we can initialize it with these curly braces, which is what I'm going to do here. You could have just created a constructor for it and then used this kind of initialization, but it's not a big deal. Now that we've got the location and the color, we can go board dot draw cell and then the location and the color C. And if you run that, you get disco fever or disco seizure or whatever. I don't know. Maybe I'll put a warning on this, but probably not. But yeah, as you can see, it's working fine. It might look really shitty with YouTube's compression, but trust me, it's doing the job it was intended to do. Alright, so now that we've got the basics of the board class all up and running, let's switch gears here and start on the snake. So I'm going to get you to, create the snake.h header file and put this code in it, the basics of what we need. Now, the snake is going to be modeled with two classes. We're going to have one class that represents the snake as a whole entity, and we're going to have another class that represents a segment of the snake. So the snake class is going to have an array of segment objects, and it's going to manage them, and it's going to be the snake class that ties all the segments together, and the snake class is what the other entities in the game are going to interact with, and the snake class is going to manage all the segments that are inside the snake. So we're going to need another class called the snake segment. Now we could go ahead and create a whole new H file just for snake segment, but since it's so intrinsically tied to snake, I feel like it's not worth it. It's better just to put it in the same header file with snake. In fact, there's something in the C++ language that can let us do even better than that. What we can do is we can cut this guy out here, and we'll put him right here. I'll just tab this over for a second here. We can actually declare, oh shit, there we go. We can declare a class inside of another class. Yes, obvious meme is obvious. Now, this gives us some advantages because the outside world doesn't actually have to know about snake segments. That's an implementation detail that's internal to snake. So if we declare this class inside of snake, this inner class, and we make it private, then the outside world doesn't have to know anything about how a snake implements its segments. It's only concerned with the interface to the snake itself. And since this is now inside of snake, we don't have to specify it's a snake segment. It's just called a segment now. I almost said smegment, which is probably something else. So what all goes into a segment then? Well, it's going to have a location, and that's going to be, the location of the segment. I'll just call this location loc. And let's give each segment a color, so it's possible to give different segments different colors. And that's all we really need for data in a segment. Alright, now what goes into snake? Well, I like to add a little private here again. It's not necessary, but I like to just mark off my member variables from other things, like, for example, this class here. And so we're going to need an array of segments. So we'll call it segments, and we have to give it a size. And so here's the problem. We have to give this array a size, but what size should we give it? You see, the snake is going to start off with very few segments, like maybe 3 or only 1 segment. And as it eats things, it grows. So, if we started off with the amount of segments that it needs at the beginning, then when it eats some fruit, your array is not going to be big enough. But if you started off with, let's say 100 segments, that's too many, right? You don't want to start your game off with that many. So what's the solution? What are we going to do? All right, so the way that arrays work, you can't change their size once you've created them. In fact, you have to set the size. It has to be known at the time you're compiling the program. And you can't make it grow or shrink after it's been made for sure. So if you have a game and you want your snake to be able to have a maximum of, let's say, 100 segments, then you have to make your array have 100 elements. That's just the way it is. Now, the way you handle this problem is, in the beginning, you only have 3 elements, let's say you have your snake starts with 3 segments. So you only have 3 elements of the array, the first 3 elements that have valid values, and you only use those first 3 ones. And the rest of them are just treated as garbage, unused, or at least not used yet. So you never touch these when you're, for example, drawing the snake. You only draw the first 3. These ones, they are not yet used. Then as the snake grows, you mark some of these unused ones as used. And in that sense, your array grows, or to be more precise, the portion of the array that you're currently using grows, and the unused portion gets smaller. Now, you got a couple of ways that you can mark off how the array is being used. You can have an element in the array whose value signifies that is the end of the array. So you call this the terminator element.
It might be a tumor.
It's not a tumor. It's not a tumor at all.
That is one way of doing it. The other way of doing it is you have a variable, you could call it size, and that just stores the number of used elements. So right now it would be 4. And the size, it not only tells you how many elements are currently used, but it also happens to be an index into the next unused element. So you can use it as an index to point to the first unused element in here. And this is the method that we're going to be using. We'll just remember the size, or the number of used elements that we currently have in our array. So we're going to define a constant here. And that is going to be the maximum number of elements we can have, or the size of the array, the actual size of the array. So we'll go this one, max n, or we'll do it n segments max, and we'll set that equal to, I don't know, how many segments do we want to have possible maximum? Let's just go with 100 for now. And then we can copy this and paste it into here. And then we're going to have another integer here, and this is just going to be n segments. So that's how many segments are currently existing, or how many elements of the array are we currently using. And we'll just start off with 1. All right, let's sketch out the interface for the snake. So first things first, we're going to need a constructor to make the snake, and we should be able to specify where the snake starts off on the grid with the location. Actually, this reminds me that I wanted to do something in here in board for the draw cell. This should be a constant reference, and let's toggle header code file. This should also be constant. I don't know why I'm in typover mode, but let's cut that shit out. We're going to add a function MoveBy, which moves the snake by a certain delta value. And what a delta value means is, for example, it's getting past a location, and let's say that delta location is equal to 1, 0. So that means moving 1 in the positive x direction, so that would cause it to move like this. We're going to want a function that causes the snake to grow, and we'll call this one whenever it eats one of the fruit. And we're going to want a draw function to draw the snake to the board. Now, the way the snake movement works isn't super complicated. Let me go over it here. What you're going to do is you're going to have each segment follow the next segment, starting from the tail and working towards the head. So if our delta location is 0, 1, that means that the head of the snake is going to be moving down. But we start at the tail, and the tail segment is going to go here. It is going to follow the segment before it. Then this segment here is going to go here. It's going to follow the head. And then the head, it has nothing to follow. It moves in the delta location, so it moves here. And in the end, you get this pattern here. So starting from the tail, follow the next one until you reach the head, and then you just move in the delta location. Now note that this wouldn't work if you tried it the other way. If you start with the head moves here. So now the head is here. This one tries to follow the head. It also goes here. And then this one also goes here. That's no good. You got to start at the tail and then follow the next one. So in the segment class, we're going to create a function void follow and constant segment and next. We're also going to add a function to draw a segment, and we're going to need a couple of functions here to initialize segments when the snake grows. I've added two init functions here, init head and init body. Init head takes a location because we have to specify the location of the head when the snake is created. Init body doesn't take that because the body is just going to follow the segment before it. So it doesn't matter what you set it to. As soon as you move the snake, it is going to move to the proper position. I'm also going to add here a couple of constants for the colors of the snake, the head and the body color. All right, let's implement these functions then. We'll start with the constructor for snake, create the definition. And so what are we going to do in the constructor? Well, we definitely want to set up the head. So we're going to go segments at 0.init head, and we're going to pass it the location that was passed to our constructor. And that's all we need to do here. Now the MoveBy function is a little tricky because we got to start at the tail and then make our way to the head. So we're going to start int index is equal to n segments minus 1. So n segments minus 1 is the last segment in the snake that's currently being used. And as long as n segments is greater than 0, because we don't want to process the head will be moved by delta location. So we only want to process all of the segments up to but not including the head. So as long as n segments is greater than, no, that was dumb. As long as I is greater than 0. Let's not do any of that here. I minus minus, or if you prefer, minus minus I. So we'll be decrementing I until we reach the head, and we will stop and not process the head. So for each of these segments, we're going to go segments at I dot follow segments at I minus 1. So follow the segment that is before you. Now here's the thing, we want to move the head by this delta location value, but we don't really have a function to do that. So let's add a new function to our segment. We'll call this void MoveBy and constant location and delta underscore location. So this function will move a segment by a certain amount. And so now we go back to our MoveBy. Let's go to definition. Here we go. And we call segments at 0 dot MoveBy delta location. And this should move our entire snake based on this value here. Now the grow function is going to be super simple. We're just going to increase the number of segments being used, the size of the array that's being used. But let's make it safe and let's check to see if n segments is less than n segments max. And we'll only increase it if it's smaller than the max. So if it's smaller than the sax, then we will... Oh wait. I always put the plus plus at the end because that's what I'm used to, but it's not, like I said before, it doesn't matter if you put it at the beginning or the end in this case, but just to be consistent, I'm going to try to put them at the beginning. Okay. So yeah, that was grow, very simple. What is next? Draw. Draw is also going to be similarly quite simple. Create definition there, and we're just going to go for loop through all of the segments. And then for each of those segments, we're just going to call draw on that segment. All right, now let's implement the functions for the segments. So I've already created them here. Let's just do it up. All right, so init head, all we're doing here is we're setting... So I did the dumb thing I always do, and I made the variable here the same as the name of the member, which is going to cause problems for us, as you can see here. So what I'm going to do is I'm just going to do in location, and that'll make our life easier. And so we're just going to assign this to this. And we can do this actually for structures and for classes. You can assign them to each other. There's actually, let me just go to it here, location. There's actually remember when I said there were a bunch of functions that are generated automatically by the compiler if you try to use them, like, for example, the default constructor? Well, there is also a function for assigning one object to another that is generated by default by the compiler, and that is called it's called the assignment operator. Actually, it's an operator, but we won't get into that right now. But basically the way it works is it just takes all the data members and it assigns them over from one object to the other. So this assignment of this one does pretty much what you would expect it to do. It assigns the x of this one to the x of this one and the y of this one to the y of this one. But anyways, just wanted to bring that up. So we'll set the location equal to that, and we're going to set the color C equal to, and we'll go snake head color. And this is an interesting thing I want to note. Head color is actually a private member, but we're accessing it from a different class. And you might say, well, why can you do that? Well, the reason is because this class is inside of the snake class. So just like when functions are inside of a class, they can access the privates. If classes are inside of another class, they can also access the privates of that class. And this can be good or it can be bad depending on your situation. In this case, I find it good. But just be aware that that's a thing that can happen, and it can sometimes break encapsulation if you don't use it properly. So, initialize the head, sets the position and the color. Initialize the body is just going to set the color equal to snake body color. Follow is very simple. All you do there is you go location is equal to next dot location. And MoveBy, this is a tricky one actually. Basically what MoveBy is going to do is it's going to add the delta value to our location of our segment. So let's create a function in location that will facilitate adding a delta value to a location. So we're going to go void add and constant location ampersand, I don't know, value, doesn't matter what we call it. And in here, we're just going to go x plus and equals value dot x and y plus and equals value dot y. Seems rather simple to me. And then in MoveBy, all we're going to do is we're going to go location dot add delta location. Very simple. Now, the thing about MoveBy is we only want to be able to move a snake by one square either horizontally or vertically. So let's be a little bit safe here. Let's include assert, and in here we're going to check to make sure that the delta is a valid delta. So assert, and we're going to assert that the absolute value of delta location.x plus the absolute value of the y is exactly equal to 1. And the way this works is because the only valid delta has to have x or y, that only one of them can be either 1 or -1. So the absolute value, and this function is just found in the standard math library, it takes on a value, and if it's a negative, it turns a negative into a positive. So 1 will return 1, -1 will also return 1. So add these two together, and the result has to be 1, because only one of these guys can be 1, and one of them must be 1, or -1. But when you do the absolute, you remove the negative part. So it's just a little bit of a nice test here that can verify that we're not passing in, absurd deltas that don't make any sense for our game. Last thing here is the draw, and it's basically as simple as you get. You just go board.draw cell and location and color C. And there you go. I hate that the freaking auto formatting puts this space. I hate that. But anyways, there you go. And that is all of our functions for the snake, for the very basic part of our snake. Let's see if it builds. So it does indeed build. Now we want to test it out. It is I, Future Chili, and here's where I'll call it today. Motherfucking cliffhangers! 2 things. First of all, you gotta slam that like button. I'm serious here. These videos, these game tutorial videos, they kind of serve as a gateway to get people into the series, just like the introduction video. And I really need you guys to slam that like button for this one. So if you like this video and you like what I do in general, hit that like button and make sure I can get more people into the series, which will help to ensure that I can continue to do the thing that I do. Now the second thing is, I'm ending this one on kind of a cliffhanger, but don't worry, if you're watching this in real time, the next video is going to be up in a day or 2 at the max. Just gotta edit that motherfucker. And if you're not watching in real time, then it's already there. But what I would, recommend if you're up for the challenge is maybe try to continue on your own now. You've got to start, see how far you can take it without, Chili. You don't need me to lead you by the dick all the time. Take some initiative. Either way, I will be there in part B of this tutorial to show you the way. See you soon.